So, how many in here like science? I mean, what are you doing in here if you don't like science? How many of you like math? All right, leave your hands up if you like math. Everyone look at those people and say, what is wrong with you? No, I'm just joking. I actually was a high school science and math teacher. So I'm with you on that. What I'd like to do is, do we have our thing up? Oh, perfect. What I'd like to do is begin with a story. It all takes place on April 11th, 1970 at 2:13 p.m. Eastern Standard Time. What do you think the significance of that date is? My birthday? See, I'm hurt now because I was born in 83. Do not let the hair fool you, okay? Wow. I don't even know if I can go on after that. This was actually the launch of the Apollo 13 spacecraft from the Kennedy Space Center in Florida. This was actually the third scheduled mission to the moon. Unfortunately, the Apollo 13 spacecraft would never actually land on the moon. Many of you probably know the story. Initially, everything was going to plan on this magnificently designed spacecraft. However, 55 hours and 54 minutes into the mission, traveling at 3,200 kilometers per hour. That's 900 meters per second. That's as fast as a speeding bullet. The crew hears and they feel a loud explosion. And then we get Captain Jack Swigert famous words, or Tom Hanks, as many of you probably know him. What was it? Houston? Yeah, we have a problem. It was a huge problem. One of their oxygen tanks had exploded. In fact, they looked at the window. They could see gas leaking into space. 2 of the 3 fuel cells are now dead. Apollo 13 has a new mission. We need to bring home the astronauts safe and sound. And that they did on April 17th. They actually brought them home, and they called this mission a successful failure. Now, why did I start with that? Well, just as the Apollo 13 spacecraft is finely tuned to support the life of the astronauts, our planet, Earth, and actually our universe, as we will see, is finely tuned to support our life, the existence of life. And so what I'd like to do is I'd like to walk through some of that fine-tuning. Now, what we say is this fine-tuning it's like it's balanced on a razor's edge. And what that means is, imagine a tightrope stretched across 2 skyscrapers, okay? Literally, on either side of the tightrope, it does not support life, right? You take one step to the left or the right, you plummet to your death. Only the narrow position on the tightrope supports life. Agreed? In the same way, the conditions of the Earth, the solar system, the galaxy, and even the structure of the universe are finely tuned to support life. You go one way or the other, and it makes life impossible. And so I don't have my computer in front of me, so I have no idea what slide's going to come up next. So what I'd like to do is I'd like to start with the Earth, and then I'd like to go into the solar system. And then from the solar system, I'd like to go to the galaxy. And from the galaxy, there it is, I would like to go all the way to the structure of the universe. How does that sound? Good. 4 of you think that sounds good. So this is actually from a much larger, I could probably spend 60 minutes, which is why I had to cut some slides, and I don't know which slides are in here. Let's start with why don't we start with the Goldilocks principle? So the Goldilocks principle, how many of you have heard of the Goldilocks and the 3 Bears? Obviously, it's the only children's story that condones breaking and entering. Okay, do not read it to your kids. 1 porridge is too hot. 1 is too cold. 1 is just right. Well, astronomers kind of like the idea of how that sounds, and so they came up with something called the Goldilocks principle, essentially saying where the Earth resides in its distance from our planetary star, which we call you're paying attention, very good, is just right. Just how finely tuned is it? Well, if you get a little bit closer, say to Venus. Venus is too hot. It's like 700 degrees Fahrenheit on its surface, okay? You go a little bit further out from the sun. That's where Mars is, and Mars is just too cold. Where we reside is what we call a habitable zone. It's just the right distance for the right temperature to support life. Now, this plays a role in actually getting water, which is also significant for life. If you go a little bit further out, you will find ice, like on Mars. They've found ice, and they're pretty excited about that because they think, well, life is just add water, right? And we're almost there. And so that's where we found that. If you get a little bit closer, you get to Venus, Now, Venus has water vapor. This is part of the problem with Venus. Venus has a runaway greenhouse effect. All that thermal energy is trapped in this blanket of water vapor. But on the Earth, we have all three phases of water. I really like that picture because it actually shows something very unique about water, okay? Not only do we have 70% covered in water, you need abundance of it, you need an active water cycle, but you also need water to have a specific property. And it's unique to water and no other natural substance that we know of. And that is, when water goes from liquid to solid, does it get more dense or less dense? You guys didn't know there was going to be a quiz. Less dense. But when I teach particle theory to grade 9s, they're thinking, no, wait a second. The particles get cold closer together, right? No, not with water. Because of its molecular structure, it gets less dense. And that is why that huge piece of ice is floating and not sinking, okay? In fact, you can try this at home. Take a glass of water, put some ice in it. If they don't float, you did something wrong, okay? Now, if that were more dense, if it was like every other substance known to man, then what would happen is that would sink to the bottom of the oceans and lakes, and they would freeze from the bottom up, killing all marine life. And eventually killing all life. They call it a snowball Earth. But you guys aren't impressed by that. Say, I'm not impressed. Say it, because I'm not going to go on. You guys are liars. Okay, so did you know that our Earth has a bar magnet inside of it? You did. It's a liquid iron core. It generates a magnetic field. Now, one of the liabilities of being so close to our planetary star is that it's being bombarded by cosmic radiation. Okay, now this was worth the price of admission here. Watch these arrows deflect. Yeah, cosmic radiation deflected. It's a shield. I know you're excited now. Magnetic field, what's next? Okay, and there's a number. I normally in this presentation I go through probably 10 to 12 different things for the Earth. Let's move out to the solar system. The solar system. Our solar system's really cool. Did you guys hear what happened to Pluto? Not a planet anymore. It's a dwarf planet. Why is it a dwarf planet? Because, give me the wrong answer. It's yeah, there you go. Because it's too small. That's what you're supposed to say, and that's wrong, okay? It has nothing to do with being too small. It has to do with its orbit. So I got the orbit here. Pluto is highly elliptical orbit and actually crosses over Neptune's. Now, I want to be the guy who made the call that says, hey, if your orbit crosses another orbit, you can't be a planet. Who makes that call? And so, by Pluto. So here we have our 8 planets. Now, something really cool about these gas giants, in particular Jupiter. Jupiter is massive. I mean, its gravitational field is huge. You can see here the red spot. That's about 3 times the size of Earth. It's a hurricane. Here's an asteroid. Now, everyone together. Oh, no, it's heading straight for us. Yeah, you guys are all future, actors. So here comes the asteroid, but you guys aren't really worried because you know we actually have, and this is what the textbooks say, we have a cosmic vacuum cleaner in our solar system, and it is called Jupiter. We literally should thank God for Jupiter because if Jupiter didn't exist, you probably wouldn't either, okay? Say, I'm not impressed. Okay, let's go out to the galaxy then. Not only are we in just the right Earth, just the right solar system, but we're in just the right galaxy. What's our galaxy called? The Milky Way, because it tastes like chocolate. No, because of how it looks kind of milky from the edge on. Now, where we reside is actually just the right position as well. Our galaxy is a medium-sized galaxy. It's about 100,000 light years across. A light year is a distance measurement. It's 10 trillion kilometers, so it's 1,000,000 trillion kilometers in diameter. I don't know who measured it. It has 100 billion stars, and I don't know who counted, okay? So don't ask that during the Q&A. But where we reside is just the right location. You don't want to be too close to the center of the galaxy. That's a black hole, and you can imagine you don't want to be too close to one of those guys. There's supergiant stars. There are supernova. Supernova is exploded star. You don't want to be next to one of those when they go off. You also don't want to exist too far out because there's no heavy elements out in the outer skirts of our galaxy. Chemistry class would be a good time. Be like, kids, get out your periodic tables. Hydrogen. And so it turns out we got to reside basically in that narrow band that I've shown there. But what I want you to do is forget everything I just told you. You're thinking already done, right? The real case for fine-tuning comes from the structure of the universe. That is, the constants and quantities that are put in kind of at the beginning of the creation event. And so there's a number of these constants and quantities. I just like to look at a couple with you. If you were to change these dials, even by the slightest amount, you can have no life. In fact, in many cases, there's no stars, there's no galaxies, there's no planets, certainly no life. And so we're talking about going from a life-permitting universe to clicking the dial over and going to, I just realized there's a TV back there. I can actually see what's going on. Thanks for letting me know, girls. To a life-prohibiting universe, okay? A life-prohibiting universe. And so, this is where I actually need my notes. What are the scientists saying about this kind of fine-tuning? How about American theoretical physicists? These are not Christians that I'm quoting, by the way. Freeman Dyson, he didn't invent the vacuum cleaner, if you're wondering. He says, the more I examine the universe and study the details of its architecture, the more evidence I find the universe in some sense must have known that we were coming. Fred Hoyle, who actually went from being an atheist to a theist, he said this: a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seems to be so overwhelming as to put this conclusion beyond question. And then I like this quote. George Greenstein, astronomer, a PhD from Yale, and he's a professor, he says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather, capital A, agency, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof for the existence of a supreme being? The answer is yes. It's not a trick question. Was it God who stepped in and so providentially crafted the cosmos for our benefit? The answer is yes. And so what exactly are they talking about? You guys have all heard of gravity, okay? It's what keeps you in your seat, okay? It's what keeps us on the earth. Every two objects in the universe are attracted to each other gravitationally. I'm attracted to this podium right now. I'm also attracted to the Andromeda galaxy 2.5 million light years away, okay? It's a weak attraction, but it's still there. In fact, this is a pickup line I used on my wife when I met her in the science library in university. We were introduced, a friend of a friend, and so I said, did you know that you're attracted to me? And she's like, excuse me. I said, gravitationally. That's a physical attraction, by the way. And so it turns out the gravitational, what time do I have till? 10 minutes, okay, perfect. The gravitational constant in the equation that we teach like grade 12 students, okay, big G, has to be finely tuned to 1 part in 10 to the 40th power, at least. That's a conservative estimate, probably 10 to the 60th power. That's a 1 followed by 40 zeros, just to give you a sense of that probability, that the chances. The chance of being hit by lightning are 1 in a million. The chance of winning the lottery are 1 in 100 million in Canada, roughly. And then the odds of being struck by lightning twice, are 1 in a trillion. And that the white zeros are the odds of getting the gravitational constant. Let me give you an illustration here. Imagine that we cover the entire continent of North America in dimes. All of it. And then, say that's a lot of dimes. Yeah. And then we're going to stack them up to the moon. Okay? You still with me? Say that's a lot of dimes. Okay, not only to the moon, like everywhere. There we go. We are going to do, I stopped. I gave up. You can see I didn't cover the whole thing. Too much work. Do it 1 billion more times, like 1 billion continents the size of North America. That's a lot of dimes. And then I paint one red, and I blindfold my announcer here, and I say, pick the red one or you're dead. That's the chance of a life-permitting gravitational constant, okay? That's the chance. In fact, he's got better chances picking the red dime than getting the gravitational constant. Another way to put it is this. Take a tape measure, stretch it across the entire visible universe in 1-inch increments, like it's a normal tape measure. If you go, okay, you mark on that one at 1 of the inches. This is life permitting. You go one way or the other way. You go one way and make it too strong, our universe collapses in on itself. You go the other way and make it too weak, and it blows apart, and you have no stars, galaxies, or planets. Okay? Capiche? And so that is, and this is not controversial science. This is coming from the secular community, okay? The cosmological constant, it's even more finely tuned, 1 part in 10 to the 1/20th power. That is a 1 followed by 120 zeros. There is, by the way, only 10 to the 80th power of elementary particles in the universe, okay? And so you can see that is very finely tuned. The one fine tuning I'm not even going to talk about is the initial mass energy distribution, and because I have to spend like 10, 15 minutes on this, but it's finely tuned, 10 to the 10 to the 123rd power. That is a hyper exponential. Even saying it makes me want to throw up in my mouth a little bit. Okay, and so you guys didn't know this was going to be a comedy routine, did you? Where am I? And so it's led many scientists like Robert Jastrow, a self-proclaimed agnostic, to say, for the scientist who has lived in his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the final rock, he's greeted by a band of theologians who have been sitting there for centuries. Because what have theologians been saying for centuries? That 20th and 21st century astronomers and astrophysicists have figured out. In the beginning, God created the heavens and the earth. This is God and astronomy, or the Bible and astronomy, I think is the title of the talk. And so what we read in Romans 1:20 says, this is Paul writing, 2,000 years ago, he says, for since the creation of the world, God's invisible qualities, namely his eternal power and divine nature, have been clearly seen, being understood from what has been made, so that men are without excuse. We are all without excuse. Even those who try and raise things like, well, okay, Tim, who made God? That's basically Dawkins' central argument in the God delusion. Well, who designed the designer? My 4-year-old knows God wasn't designed, okay? Knows he wasn't made. He is an unmade. He's the uncreated creator. By definition, open your Bible, Richard, and you would see that. And so we can obviously answer some of these challenges. Am I down to 5 minutes? Oh, perfect. I'm going to keep going then. It's no wonder that David said, the heavens declare the glory of God, the skies proclaim the work of his hands, okay? In fact, Isaiah said, this is God speaking through Isaiah, to whom will you compare me, or who is my equal, says the Holy One. Lift your eyes, look to the heavens. Who created all these? Who brings out their starry host one by one and calls them each by their name? And just look. This is the Hubble Deep Field. This was a patch of the night sky that they thought was empty. It was dark. It was just black. They focused the Hubble telescope, the space telescope, for 10 days, and they got an image back of 10,000 galaxies. Yeah. Whoa. That's awesome, right? The heavens are truly awesome. And I think I showed there's a spiral galaxy. I just love spiral galaxies, I guess. Just so we get a sense of how big the universe is, going from one star, like our sun, let's climb in, go from our sun to another star, traveling our best technology, going at 8 kilometers a second, which is as fast as space shuttle goes, it would take 200,000 years. And we think we're going to explore space. The heavens are truly awesome. Here's some pictures of some galaxies. I would just point this out. Here's a globular cluster. Turns out where we reside in our cosmos is not only finely tuned for our existence, but it seems to be finely tuned for observation. If you lived in that globular cluster, say globular, such a great word. M4, if you lived there in the center, you would never even know that there was other galaxies out there because we'd be bombarded by radiation, so you'd be dead. But you'd be bombarded by light all the time. Okay? Just go into Toronto and try and look for the stars. You'll see, hey, they're not there anymore. No, they're there. You just can't see them. I want to show a video quickly of my hero. No, he's not my hero. Bill Nye, the science guy. You guys have heard of him? Hopefully this works. Let's try this. Not going to work. No? Okay, forget about the video. You never saw it. So Bill Nye basically says, here's what he says. We're just a speck on a speck, a speck on a speck on a speck on a speck on a speck. And he says, we suck. That's his term, not mine. And so what he's saying is, look at the galaxy. Look at the universe. We're just a speck. Our galaxy is just a little speck. And then our solar system is a speck inside the galaxy. And then finally, our Earth is just a speck inside our solar system. We are truly insignificant, is his point. We are insignificant. In fact, Carl Sagan, Famously, in 1990, the Voyager 1 space probe was traveling. It was leaving our solar system. Carl Sagan had it turn around and take a photo. I don't know if you can see right here, kind of caught in this ray of light coming across. That's Earth. That is Earth. And so basically, we're just a speck. We are insignificant. But this really, Bill Nye is an atheist. He's obviously come out with that, and it's clear that he is. That's the only conclusion you can come to, is that we are a speck. We are insignificant. We are no one special. But when I look at the heavens and see the size of it, I conclude two things, and you should conclude the same. First, the heavens declare the glory of God. Why are the heavens so big? It just seems like a waste of space. No. God's basically showing how awesome he is. If he made it smaller, you know what the atheist would say? No, look at all this wasted space. Wow, your God's so small. He only made a small galaxy, not a big one. So the objection is going to come either way. And not only that, I think it shows that we are special. I was at Saddleback, Rick Warren's church, speaking to the youth group there, and one of the girls said, "We're not a speck, we're spectacular." So I'm like, yeah, that's good. I'm going to put that in there. So, and this is what David says. It's when I look at the heavens, the work of your fingers, the moon, the stars, that which you have set in place. What is man that you are mindful of him, the son of man that you care for him? But the answer to that is he does care for us. Every fine-tuned condition we just looked at was put in place for us, for our survival. And so not only have we been talking about fine-tunedness and design, but I think we've been talking about God's love, because the Bible, in fact, David says, "For as high as the heavens are above the earth, so great is his love for those who revere him." As high as the heavens are above the earth, how high is that? We don't have a clue, okay? We don't have a clue. It's high. And so that's how much God loves us. And I'll end with, I think I got 2 minutes to spare. I'll end with, not only does he love us that much, we're not just, you could make the argument, wow, God's made this really cool ant farm for us. You know what I'm saying? We're like his pets or something. But it's not even close to that. Not even close, because he actually, that pale blue dot, that speck, he actually came to on a rescue mission to seek and to save us. So this whole time, I think we've been talking about God's love. And it's quite a remarkable thing. I'm going to leave it at that and take one question. In fact, we'll do Q&A with only Q, no A. Some of you guys are going to get that in about half an hour. Okay, so